Hello again, everyone. Right now we're going to take a quick look at the quotient rule. The quotient rule is used if you want to find a derivative of a quotient of two functions. The quotient rule says the derivative of f of x over g of x is equal to g of x times f prime of x minus f of x times g prime of x over g of x squared. This is really hard to remember in this form, so we use a mnemonic device that's famous throughout calculus. That mnemonic device is low d high minus high d low over the square of what's below. It looks like this. Low obviously is the denominator, high is the numerator, d high is a derivative of the numerator, d low is a derivative of the denominator. So your low, that's your g of x, your denominator. D high, that's a derivative of your numerator, f prime of x. Minus high, that's your numerator, f of x, times d low, that's a derivative of the denominator, g prime of x, over the square of what's below, that's your denominator squared. Let's take a look at a couple examples. Find h prime of x for h of x equals 5x minus 2 over x squared plus 1. So our derivative, h prime of x, would be equal to, since we have a quotient, we're going to use a quotient rule to find the derivative. Quotient rule is low, that's our x squared plus 1. Low d high, the derivative of the high, derivative of the numerator is 5, minus high, 5x minus 2, d low, the derivative of the low, the derivative of the denominator is 2x, all over the square of what's below. That would be the quantity x squared plus 1 squared. Generally speaking, we want to leave the denominator in a factored form, but we can clean up the numerator a little bit. So I'll have 5 times x squared plus 1, which when we distribute the 5 gives us 5x squared plus 5 minus, and then 5x minus 2 times 2x is going to give us minus 10x squared plus 4x. Still all over that x plus 1 squared, or x squared plus 1 squared, I'm sorry. So all said and done, we would have negative 5x squared plus 4x plus 5 over x squared plus 1, that quantity squared. Every now and again you can factor the numerator and cancel a factor in the numerator with one of the factors in the denominator. That's not common, but it's still something that you should look into, because if you have to find a second derivative, you want to make your first derivative as simple as possible before finding your second derivative. Let's take a look at one more example. Find dy dx for y equals cosine x over x cubed. Again, we have a quotient, so to find a derivative we have to use a quotient rule. Low d high, low is x cubed. D high, the derivative of cosine, is negative sine. So it's low d high minus high, cosine x, d low, the derivative of the denominator, x cubed, is 3x squared over the square of what's below. So we have x cubed, that squared. Cleaning that up a little bit, we'll have negative x cubed times sine x minus 3x squared cosine x. All over x to the 6th power. Now this is one of those cases where we can simplify a little bit. We can factor out and cancel an x squared from the numerator and an x squared from the denominator. So after we factor out an x squared and cancel, we'll be left with negative x sine x minus 3 cosine x all over x to the 4th. And that's it. So again, the quotient rule, just remember low d high minus high d low over the square of what's below.